Uh, in this video, we'll discuss about the thick cylinders. Okay. In the last previous 6-7 videos, we are discussed about the thin cylinders and the what are the stresses developed and related to problems. We solved all the problems related to thin cylinders. Now we'll start the thick cylinder. The next unit here. It's an introduction part of the thick cylinder. First, we'll discuss what is the thick cylinder. Then we'll go thoroughly about the how the stresses developed and what are the patterns and everything we'll explain here. Okay, we'll go to the introduction here. If you go to the first point here, thick cylinders are characterized by lower value of inner radius to the wall thickness, right? Its ratio, as we know that in case of the thick cylinders, the ratio of the inner radius to the thickness is less than 10, right? It means it is characterized by lower value of inner radius to the wall thickness. It means in case of thick, the name itself it is say that the thickness of the cylinder, the thickness of the wall thickness is more here, okay, but the inner radius is less. The compared to that, the thickness is more here, okay. So whereas in case of the thin cylinders, it is opposite, as we discussed earlier. That is, the thickness is less and the inner radius is more, right? Therefore, the ratio, the inner radius to the thickness is greater than 10. Is greater than 10. That is the first difference. The thick cylinder. Next, if you come to the second point here, as in case of thin cylinders, the thick cylinders also subjected to circumferential stress and the longitudinal stress, right? So as we discussed the problems and the derivations in case of thin cylinders, the circumferential stresses developed and longitudinal stress are developed here. In the same case, here also in case of the thick cylinders, it is subjected to circumferential stress and longitudinal stress. Okay, so that is the second point. Same like thin cylinders. If you go to the third point, spherical vessels, thick spherical vessels are subjected to only circumferential stress, right? Because it is a sphere. It is only subjected to the circumferential stress. There is no longitudinal stress here. Okay, as in case of thick cylinders or thin cylinders, there is no longitudinal stress developed in the thick spherical vessel. Okay, that is one point. Next point is thin walled cylinders are subjected to negligible magnitude of radial stress. Okay, so one more type of stress it is coming here. So radial type of stress. In case of thin cylinders, there is no radial stresses are developed here because of the less thickness. But in case of the thick cylinders, we have to consider the radial stress also. Radial stress distribution, circumferential stress distribution and the longitudinal stress distribution. These three will be main points in case of the thick cylinders. But in case of the thin cylinders, it is neglected. Radial stress is neglected because of the thickness of the wall. Along the thickness of the wall thickness is very small. Okay, just I'll read here. The thin walled cylinders are subjected to negligible magnitude of radial stress. Okay, radial stress, because along the thickness of the wall, it is along the thickness of the wall, as their thickness is very small. This is one difference in case of the thin cylinder and thick cylinders. So next point is it is opposite. Okay, this is the opposite point, the opposite to that is thick walled cylinders are subjected to considerable magnitude of the radial stress, right? Considerable magnitude of radial stress. It is along the thickness, right? Along the thickness of the wall. Along the thickness of wall. Because thickness is larger. Because of large thickness. This is one difference, right? The thin cylinders are not subjected to the radial stress because of the the thickness is very small. But whereas in case of the thick cylinder, they are subjected to the radial stress along with the circumferential stress and the longitudinal stress because of the thickness is very large here. Okay, that is one next point here. So if you go to the next point here, the next important point is, in case of the thick cylinders, as I said, one is circumferential stress, one is longitudinal stress, one is radial stress. These three are developed. But the circumferential stress and the radial stress, it is vary along with the thickness. Longitudinal stress remains same. That you should remember here. Longitudinal stress remains same along with the length of the cylinder and the throughout the cylinder. But the circumferential stress and the radial stress, it will be vary at the in the thickness here. Okay, that is one point. So in thick cylinders, circumferential stress and radial stress vary along the thickness. But longitudinal stress remains same. Okay, this is one more important point here. Longitudinal stress remains same, but the circumferential stress and radial stress, it will vary along the thickness. Here. This is one more important difference here. Okay, so how the stress distribution. These are all the difference between the thin cylinders and thick cylinders. Okay, so just again the recall here. In case of the thick cylinders, R by T is less than 10. That is one difference. That is one important criteria. And next one is the stresses. Whatever the stresses developed in both cases, the circumferential stress and the longitudinal stress, both the cylinders, it will be developed. Okay. But in case of the thick cylinders, one more extra stress developed. That is radial stress. Because the thickness is more, the radial stress also comes into consideration. And these three are the stresses developed inside the thick cylinders. And the circumferential stress and the radial stresses, it will vary along with the thickness. Okay, in case of thick cylinders. But the longitudinal stress remains same here. Okay, this stress distribution pattern and what are the stresses developed, all these three stresses equation we will derive with the help of the Lehm's equation. So that is the equation, it is called as the Lehm's equation. Okay, Lehm's equation, and this we will derive in the next video, how the pattern, stress distribution pattern, and what are the stress equations, we will derive this equation here. This is how the introduction of the thick cylinders.